I have one aim in this video, to show you some tricks that will level up your PromQL skills and impress your teammates. We will explore a lot of underrated tricks like predicting the future, combining labels, and even event-based alerting. I have a sample application running locally which simulates a basic food ordering service like Uber Eats. I'm tracking a wide range of metrics that let me know both the health of the application and the rates of orders. One underrated trick you could use in PromQL is to record the timestamp of a particular event and use that in your alerting. For example, I want to know if the number of requests to my service is below a baseline, but only care if there have been no subsequent orders in the last 10 minutes. If you've come across this situation with Prometheus metrics before, then you know it's not possible with normal metrics. What you have to do is export a metric that records the last successful event. I have done that here with this metric that tracks the last time we received an order. As you can see, this metric is even organized by region and by different order types. Now I want to know if the rate of request to my service is weird. I have the HTTP request total metric for that. To establish a baseline, I can query for the rate of requests and see what normal looks like. So clearly, if the rate of requests is less than 1 every 5 minutes, I can safely assume something is wrong. But what if this is normal? What if this is just a slow day? I'd prefer to make my alerts even more useful by only notifying me if there has been no subsequent order in the past hour. Let's experiment with this a little bit. I can simply do this by taking the timestamp of the last order and adding it to the query. I am taking a max so that the timestamps are aggregated across all regions and all order types. I can then subtract the last timestamp from the current time, which gives me the number of seconds since the last order. Finally, I can add a condition that checks if the number of seconds is greater than 5 minutes, which is 5 multiplied by 60. The last thing to do is to combine these two queries together. This is a simple but powerful way to not only alert on thresholds, but on known events within my system. Another underrated feature of PromQL is the ability to predict the future. With the predict linear function, you can estimate what the value of a metric could be at a particular point in the future. This feature is based on simple linear regression, a subset of machine learning algorithms which form the basis for a lot of AI advancements you've seen today. I'll talk more about machine learning algorithms in upcoming videos. The most common example for predict linear is estimating disk usage in the future. This is not surprising because you should only expect to reasonably use this prediction on a metric that exhibits a consistent pattern. The disk usage of a server is likely to increase steadily, especially if it only accumulates log files. It would be a mistake to try to predict a metric with very wide variance, like the number of errors per second or CPU usage. So let's try to see how prediction behaves for our system with various metric types. The disk usage on my machine is pretty constant. So if we try to predict what it will be in an hour, we can use a query like this. By providing a range vector for the last 24 hours of data, we tell Prometheus to use all that data in the prediction. This range of data is an example of something you can tune depending on your use case. 60 times 60 here represent the point in the future that you want to predict, which is 1 hour. My predicted disk usage in the next hour is the same, since the number of free bytes is constant. In production, you can create an alert that notifies you if the predicted value at some point in the future is less than 0. This means you've run out of space. Now let's see an example of a poor metric. The CPU usage of this server is very sporadic. I don't recommend running a prediction on this as there is no discernible pattern. If you take some time to understand how linear regression works, you will learn that it's mostly about fitting lines through data points and using that line to predict a future value. If I run a prediction for the CPU usage 1 hour from now, I'll get a value I can't really trust, and the graph shows that the predictions are all over the place as well. Only run prediction on metrics that have a discernible pattern. For more complex forecasting or machine learning, it's best to export your data and use an actual machine learning tool. Stick around for my video on machine learning algorithms to learn more about patterns. There are some subtle cases where you will need to do some if-else or branching logic in PromQL. Using if-else logic in PromQL, you can transform data using the logical operators, set different thresholds for different targets, or simply just make your query smarter with conditional suppression. As an example, let's say I want to plot a graph for an increased rate of errors, but only care about the errors that happen when traffic numbers are at a certain threshold. I can use simple conditional logic to only show increased error rates when the total number of requests per second is greater than 1. This logic roughly translates to: if there are increased error rates, check if request rates are above a threshold, else do nothing. I don't think this example is useful in practice, it's just for illustration. A more useful example is if we want to be stricter with CPU spikes in an alert. We'd only alert for a CPU spike if there are application errors as well. That would look something like: aggregate the average CPU utilization for all the services, and add conditional logic that checks the rate of errors across all services as well. This query roughly translates to: if there is a relatively high CPU usage, check if there are application errors as well, else do nothing. I encourage you to explore the PromQL logical operators to see how they could help create if-else scenarios. It could also be useful to group labels into one on the fly. For example, the CPU metrics I have are split per region. Using the label replace function, I can group all US regions into one label and all Europe regions into another. This query takes the average using a new metric called region group, and now I can see the average CPU usage per country, not just split regions. And if you want to see how label replace works, this video is getting a bit long, so I'll cut it short here. Let me know if you want to see more useful tricks in the future.